13 of Neetcode 50's container with the most water. So you will be given many bars, if I can call them this way, and you're gonna have to find the maximum volume of, let's say, water that these bars can contain. So you might have guessed it, we will use a two-pointer technique to solve this problem. And basically, we're gonna start with a pointer at the at the top left and the top right, and we're gonna check which bar is the shortest one, and we're gonna take the area of that shortest bar until the right pointer. So here at index 0, you have a bar of 1, 2 units I, and you basically have a length here of 1, 2, 3, 4, 5, and 6. Okay, so 2 times 6, we have an area of 12. So until we find something greater than 12, or the area is going to be 12. So now we want to check which bar, is it the right pointer or the left pointer that is the smallest one. And since in our case the left bar is the smallest one, we want to increment its count by 1. So we want to take the chance to get a higher bar. In this situation, we're not lucky because we find a bar of 1 unit high, which has a distance between its bar and the right pointer of 1, 2, 3, 4, and 5. So 1 times 5, it's giving us an area of 5. So is it greater than 12? No. So we keep going, and our area is still 12. Okay, so now our left pointer is smaller than the right pointer, so we're going to increment our left pointer by 1. We see now that we have a bar of 1, 2, 3, 4 units, which is basically the same as the right bar, which is 1, 2, 3, 4. And the distance between both is 1, 2, 3, and 4. 4 by 4 is 16. So the area that they cover is 16, which is greater than 12. So we are going to return not 16, but we're rather going to, well, we are going to return 16 because in this problem, we don't have to return index. We have to return the area itself. So it's going to be 16. Okay. So we first have to create our left and right pointer. Left and right equals, where the left pointer starts at index 0 and the right pointer starts at the index of the length of the height, -1. Okay. And we will first start with an area, or I would call it output. I like to call it this way. Let's say that it is 0 at first, because if we are given an array with 0 eighths at all, well, the greatest output is going to be 0. And this is the two-pointer technique. So we're going to loop while the left pointer is smaller than the right one. And we want to calculate the area. And basically, as we saw previously, it's going to be the minimum height between the left bar and the right bar. And this is going to be multiplied by the distance between the right index and the left index. So right, R minus L, okay. And the output is going to be equal to the maximum between the previous output and also the area. Great. All right, so now to make this loop keep looping without continuing until infinite amount of time, we want to check if the left bar is smaller or greater than the right bar, and increment or decrement the necessary bar. So we will do so by checking if the heights of the left bar is smaller or equal to the heights of the right bar. And in this case, we want to push our left pointer by 1 to the right. Otherwise, it means that the right bar is smaller than the left bar. So we want to push our right pointer to the left, just like this. And it is as simple as these 13 lines of codes are. We then can return the output. And there you go. The container with the most water takes a little while. Answer. Why is this the wrong answer? I forgot a S. Excuse me. There you go. This is how you solve the container with the most water. I hope you learned from this video, and I hope to see you in the next one.